because recent trends, all the participants, the paper presenters will give you the insight of that. So I chosen a topic which is the future of software engineering. The contents are more based on the future of software engineering research rather than, and I have based my talk on the findings of a group called as NIT, and the whole of the report for software engineering research is available on this site. Now, if you really see that what a software engineering is, it's a matter of living for software engineers to write codes. Simple. And they want to do this, manipulate this machine to do anything they think of. Take their ideas, take our ideas to make and wrangle with the machine to do something which makes the world better, which makes our life better with the use of the technology we have as of today. Now, recently, it's a matter of time that computer has taken place in our mind, in our body, everywhere. Everywhere you go, you just find that it is all over computer and computer available and doing the things. So we are doing the things to make the life more useful, more better, the world more better. Learning to code and learning to wrangle this machine along with many, many ideas you have in your mind to make use of the tools available are all the things which make the life or world better. And software engineering is one of the tools to make the life or world better. And it is not really a very tough job to see what software engineering is going to be in the next 20 years or 30 years or even 50 years. Because you see really, we are more dependent upon the lines of code, and we expect that in the next 50 years we'll have trillion lines of code on which we'll be dependent upon. But the main problem is that we don't know how to write a code. There is no clear-cut understanding the fundamental scientific way to create a software. I see that there's a saying, a finding by an article, Designing in Digital Future, somewhere in 2010, given by Picard. Leadership in software is important for our economy, for our security, and for our quality of life. And this will be more evident when we go through the papers in this conference. The future advances will depend upon our ability to cost effectively develop and sustain the transformable system of our tomorrow. But you know that everywhere, not in India only, everywhere the constraint is money. In this fund constraint or budget constraint era, we can call it, advances in software design and productivity will be needed for critical improvement in the nation's infrastructure to promote the new missions, new critical missions, and many more things. Now, for example, today we cannot express computation in natural language. Computer power or computation power remains inaccessible to most of the system. We cannot adequately verify that software runs our banks, medical services, defense system is sufficiently safe and reliable and secure. Because both complexity and reliance on software go, so our risk also goes. Health and prosperity are also dependent upon this software. Our record of producing software for major societal infrastructure system, for health, for defense, and many more areas, you can name any other area for this, remains unacceptably poor. So, why? Because we yet not fully understand how to design software for affordable sustainability over decade lifetime of the major infrastructure systems. It's not saying that we have not done anything. The contributions of past software engineering research to our society have been just stunning. Today, the software engineering research community and the computer science and engineering research community are ever increasingly rich and vibrant. The need for and the promise of future research is compelling. Yet clouds are now on the horizon. The very success of software industry and of software of all industries has led to some that major open problems in software design and productivity. We shall see it later on. I'll just go through, not in much, but that you can see now the basic national cyber infrastructure, mission critical systems like communication, healthcare, power grid, transportation, weather forecasting, agriculture, finance, defense, disaster response, and other scientific research infrastructures, they are dependent upon the software. So it is a major thing to done. The economy also depends upon, because the software is made for, whether for incorporating into products, for manufacturing products, or for designing competitive products. You can list many more as you want. So the main idea is to design, produce, assure, evolve software-intensive systems in a predictable manner while managing the risk, the cost, the schedule, and the complexity. So this is the major thrust upon of this talk, that how to do it, and that too keeping in future. Assume that you have to calculate taxes on all online purchases for any location. What software you will make and how will you make it? A distributed traffic regulation system for a network of self-driving cars and maybe drones after 50 years. How will you design it? Something like asteroid mining is another horrible thing which you can see of. Some of the solutions with social network technology for software engineering. You should advance fundamental knowledge of design as a socio-technical activity. Now, how to do it? Now you have the free open online collections of software projects that have indeed reached to the critical masses. I'll give you an example. Sethi Pribash, the current CEO and Chief Engineer of SCVGNR.com, created his first startup company, Giftopedia.com. You must have visited that. In 2001, when he was just 12 years old, offering an internet service to help people decide what gifts to buy for their loved ones by revealing what others were buying. Not knowing how to program, he found Russian and Indian programmers or software engineers through internet to build this site for him. After communicating his vision, design specifications, work ethics, using his blog, Skype text chat, and email conversation, he was able to bring his site live on social media to virally market his products. I can see that what is the use of all these social media sites. So that can be one of the major tools to help make people more communicative across the whole of the software life cycle and whole of the world. So, if you broaden the participation in production and use of software by advancing your understanding of and motivations of these skills in trace, domain-specific abstractions, etc., you can help people to produce the software you need. Most of the challenges are that develop individual software developers. Make a team of engineers, which is a scrum of, say, 5 developers, 4 testers, 2 requirement engineers, and 1 manager. Have independent software vendor and domain-specific application organizations made of many cross-functional teams. Mobile and web service vendors, as well as banks, hospital, scientific research organizations, defense, aerospace companies, and government services. Have more things like operating system specific products along with third-party vendors and consultants. Have application-specific software stacks. The examples today are LAMP, the Oracle, the SAP. Develop more mobile phone platforms like Android and iPhone. Have more open source development forms such as SourceForge, GitHub, MSDN, where you can have predominantly the forum of development is just an integration rather than the feature creation. Second thing is automatic or automated programming, that is building the complex systems of the future. Because you have the more automation, you will have the more automatic programming. So, because our society's most pressing problems demand information systems of unprecedented complexity, working within demanding application domains such as healthcare, energy, transportation, defense. The researchers should work first to characterize the fundamental information processing problems in these domains and develop the science and technology necessary to enable the development of larger scale software-intensive systems to achieve the improvements in these domains. Then we must also learn to exploit large emerging platform opportunities. That is, produce the fundamental knowledge in programming abstractions, in architecture, in the verification needed to harness the potential of a new diversity of computing devices, from the microscopic to the handheld and mobile to massive parallel hardware to larger scale, the cloud-based infrastructure, which is coming up very, very fast. Next, you should have a potential to create dependable software-intensive systems like user-friendly programming. Develop new approaches to computer-assisted iterative refinement of formal natural language specifications into, informal natural language specifications into computer programs with increasingly constrained semantics resulting in executive code, precise specification, test set, and many more. Develop the foundations to process natural language and other human nodes to expression linked to automated software synthesis that would broaden participation in computing while improving software design and productivity. You should also automate software evolution. That is to translate lower level language to more higher level language and reaching finally to human understanding languages. Then we must also try to invest in research and to improve decision making, evolution, and economics. That is, you advance the planning and management system of the evolution. Develop and evaluate evolution of your software process and practices, models of software evolution to include cost, models that adequately model evolution itself, improve data collection and analysis software decision making methods. We generally do data collection and do less analysis. Conduct fundamental research to improve cognitive support for software development, decision makers, and decision making. Right. I was talking about the investment in future research methods. So develop and evaluate evolution-aware software process and practices, models of software evolution to include software cost models that adequately model evolution-related costs and software tools, and representations capable of describing and modeling software. Now the basic idea is that software engineering is largely a human activity. Now how can we utilize the social engineering research into that? This is not to say that a software engineering person should also be a social research person. But can we really find out the methods of social sciences such as psychology, sociology, communication, and maybe economics to really integrate with our findings in software engineering? This is trivial in my opinion for two reasons. We are not expecting that all software engineering persons should be experts in social sciences methods. We also know that to understand the social sciences research is a very, very big task for an engineer and particularly a software engineer. The challenges is to identify the software engineering methods who can be aware of the facts and find and utilize the research methods of social sciences and make the software engineering picture. We should invest in research to improve decision making. We should invest in research to make evolution of software engineering and also economics. Improve the data collection methods, improve the methods for analysis of software to help you in decision making methods. Finally, develop approaches that combine traditional software analysis with techniques used in data analytics, business intelligence, data mining, prediction models, empirical studies, and economics to yield improved software development process and a new generation of software tools, improving software productivity by eliminating the necessity to rework due to poor decisions early in the development cycle by better adapting system designs to these environments. Yeah, I end my talk about this future of software engineering. Any questions, please? Thank you.